Okay, before we dive into specific OOP features, let's discuss some basics, starting with terminology. The word class means a category of things. So for example, in the lesson on basic Java syntax, we introduced strings. String is a class, it's a category of things. And in Java, a class name can be used as a type of a variable or as a return type of a function of a method. Now there's some fancy uses of classes, such as with generic types that we'll cover later, but for now, just remember that a class, such as string, can be the type of a variable or the return type of a function. The word object is not synonymous with the word class. Class means a category, object means a particular item that belongs to the category. It's sometimes also called an instance. So for example, string is a class. The variable s1 or the value hello are objects. They're instances of the string class. Now, if you come to Java from C++, Java will look a little bit familiar to you, but once you dive under the hood, you'll see that the Java take on object-oriented programming is substantially different than the C++ way of approaching object-oriented programming. On the other hand, if you come to Java from C#, you'll see that both on the surface and under the hood, the two approaches are very similar. Now, if you're not a C++ programmer, skip this slide entirely and go on and start off with the examples with instance variables. However, if you are a C++ programmer, I'd like to summarize some of the main differences under the hood between the Java approach to object-oriented programming and the C++ approach. So in C++, you can have regular functions and you can have member functions, functions that are part of classes. In Java, member functions, methods, functions that are part of classes are the only kinds of functions that you can have. There's no such thing as global functions in Java. In Java, if you define a class and you don't say what its parent class or its superclass is, then its parent class or its superclass is automatically a class named object. This is not true in C++. In Java, when you have objects of various different types, and those objects belong to classes that have methods, and you call a method on a variable, Java always uses the runtime most specific type of the variable to decide which method to call. The type that you declare the variable to be is irrelevant. The actual most specific type that it is at runtime is what matters. In Java, that's always the case. In C++, it may or may not be the case, depending on how you declare the function. Another way of thinking of that is that Java methods are like C++ virtual functions. Now, C++ has this thing called RTTI, runtime type inferencing, that lets you find out some information about the types of objects at runtime. But in Java, it's easy. You can always query an object and say, are you an instance of this class? Are you an instance of a subclass of the given class? Now, the word heap and the word stack are kind of complicated to understand if you're not a computer scientist, but the basic point is that in C++, the phrase s is a string and the phrase s is a pointer to a string are not the same thing. Or C is a circle and C is a pointer to a circle are two different ideas in C++. In Java, it's the same. You don't make a distinction between those two statements. The proper way to say it in Java would be S is a pointer to a string or a reference to a string, or C is a pointer or a reference to a circle. But since you can't do it both ways, nobody ever says that. So in Java, you always say S is a string, or C is a circle. You don't say it's a pointer or a reference to a string or a circle, even though under the hood it really is. And finally, in C++, a class can have two immediate parent classes. In Java, you can have a parent class, you can have a grandparent class, you can have a great-grandparent class, but you can only have one immediate parent class. However, as we will see shortly, Java does let you implement more than one interface, and as of Java 8, interfaces can have real methods. So in some sense, Java 8 now has multiple inheritance, but not in the way that most programmers are used to it. In particular, even in Java 8, you can only have one immediate parent class of a class that you define.